All right, thanks for coming. We're going to go ahead and look at number 4 up here, and we're looking to find if these are all, if any of these points are a solution to the system. So I'm going to go ahead and start with A, and what I'm going to do is I'm going to plug it into the bottom first. I'm just going to always plug it into the bottom first because a lot of times we try to trick you on the first few, so we'll go ahead and look at the bottom and see if that works. So we're going to plug it in. Now we do need to be very careful. So we have what, positive 4, positive 2, negative 5. So that is 6 minus 5 is 1. So 1 equals 1. So it seems like it works for at least the bottom one. We'll go ahead and check the middle one and see if it works for that. 2 times negative 4 minus a negative 1 plus a 1. So this is negative 8 plus 1 plus 1 is really not equal to 2. So doesn't work for that one. Now we're going to go ahead and look at the next one. So we'll erase this, get ready to go. So we're going to go ahead and look at B. So start plugging B into the bottom. We'll start with the bottom again. Let's use a different color just so we can see what's going on. So we're plugging in negative 2 minus a 2 times a negative, nope, not a negative 1. Sorry about that. Trying to be careful here. Times a 1 minus a 5 times a negative 1. So we have negative 2 minus 2 plus 5. That gives me 1. So it does work for the bottom one. Now we'll go ahead and plug it into the second one. So we have 2 times 2 minus 1 plus a negative 1. So we have 4 minus 2 is 2. So it does work for the middle one. And then we'll try it for the top one. We have 2 plus 2 times 1 minus, because it's going to be 5 times the negative 1. So this gives you negative 1 equals negative 1. So we found one. This guy here, B, works for the system. So now we'll go ahead and try another one. We'll try C. We're going to put C into all 3 equations. Again, we're going to start putting it into the bottom one. So we'll do red. We're going to look at C now. So we are very careful. We have negative 5 minus 2 times negative 8 minus 5 times 4. So be very careful. We have 5 plus 10 minus 20, which does not seem to work. Let's just double check it and make sure. We had a negative 5. We had a negative, oh, that's not 10, that's 16. All right. Let's see if that is. That is 21 minus 20. Boy, am I glad I checked that. That is equal to 1. So it does work for the bottom one. All right, but did you see how I checked that? You just double check. Make sure you did all your math right before you decide it doesn't actually work. So it worked for the bottom one. Oh, I don't know why I erased that, but I sure did, didn't I? All right. So now we're going to plug it into the middle one. So we've got 2 times a negative 5, and we have a minus 8, and we have plus a 4. So this is negative 10, positive 8, positive 4, so 8, 12. So that is equal to 2. So it does work for the second one as well. And now we need to plug it into the top. So this is good practice. Negative 5 plus 2 times a negative 8 plus a 5 times a 4. So double check, make sure I plug them all in correctly. Looks like it. So I have negative 5 minus 16 plus 20 is negative 21 plus 20, which is equal to a negative 1. So this guy here works for all three of them. So last but not least, we need to go ahead and try D, just to see if we were awesome and came up with 3 answers that worked, or just kind of awesome and came up with 2 answers that worked. So let's go ahead and go back to, let's go back to green. So plug in 0 to the first one, that disappears. Then I have negative 2 times negative 2 minus 5 times 1. Double check, that looks good. So that gives me, what, 4 minus 5 is equal to not positive 1. So it does not work for that one. So we do have 2 answers. Now, trying to figure out just kind of randomly another solution is pretty tough. But what we're going to do instead is to look at generalizing the solution. So what we're going to do is we're going to, let me make this a little bit smaller and move it over so give me some space. We are going to solve for the system. So as usual, you need to eliminate one of the variables all the way through. I really like the y to be eliminated. The reason that I like that is I have a negative 2, a positive 2, which will nicely go away, and then I have that nice little negative y there. So I'm going to put the top and bottom one together first, and I don't have to do anything special to them. So the x minus the x is 0. That's nice. The 2y minus the 2y is also 0. And then I ended up having 5z minus 5z is also 0. And that is equal to 0. So that lets me know that there is going to be an infinite number of solutions. So the question is what are those types of solutions? What do they actually look like? So now I'm going to put the top and middle one together. But when I do so, I need to eliminate one of the variables. So what I'm going to do is multiply through the second one by a 2. That'll give me a 4x, a minus 2y, which was my goal, yay, and also a 2z, and then that is equal to 4. Now before I move on, I'm just going to double check. So I multiplied 2 by 2 to get 4, 2 by negative 1 to get negative 2, 2 by 1 to get 2, and then 2 by 2 to get 4. Good. So that looks good. This ends up being 5x plus 7z is equal to 3. So the question is does this seem to fit what we have there? So I'm going to go ahead and look back at B. B is saying that if I have 5 times 2 plus 7 times negative 1, that will equal 3. And 10 minus 7 is 3, so that works. I also want to look at C. I'll go ahead and do red since I did it in red. That 5 times my negative 5 plus 7 times my 4 is equal to 3. So here I have negative 25, and I have positive 28, and that's equal to 3. So yes, that works. What that tells me, so I'm going to go ahead and erase all this fun stuff up here from you. What that tells me is that I can figure out a lot of other answers to this solution. And what it is that I do is I use this guy here to help me with that. So what I'm going to do is I am going to just simply pick an x value. So we're going to go ahead and just say let's pick, let's pick, I don't know, 4. So we're going to do 5 times 4. If my x was 4, then I'm trying to figure out what my z would have to be. Ooh, I rhymed. So I would have 7z is equal to, subtract the 20, and I would get a negative 17 here. Ick. That's really ucky and yucky and poopy. Let's see if we can pick another number that looks a little bit nicer. All right, so we're picking a different number that might work out a little bit differently. Let's subtract that part. And let's, oops, no, I don't want to subtract that. Just kidding. All right, so I am going to pick 9 for x. So I'm going to go ahead and plug in 5. We're going to make that a 9. 5 times 9 plus 7z is equal to 3. And I am going to get 7z is equal to, this is 45. When I subtract it, I get 42. So I end up getting that 1z is equal to a nice, pretty little 6 there. But you know what? That needs to be a negative, doesn't it? Because I subtracted 45. And so I got my negative 42, so then I end up getting a negative 6. So 9, negative 6. Now, the last thing I need to know is what would my y value be. I don't know what that is yet, so I can plug it into any one of the equations. So I'll go ahead and use green to see here. So I'm going to plug it into the middle one. It doesn't really matter which one I plug it in. So I'm going to have 2 times the 9 of my x minus y is equal to, plus negative 6 is my z, and is equal to 2. So I'm going to have 18 minus 6 is 12. And so then I get that negative y is equal to negative 10, and y is equal to 10. That is a bad number. So I would have, again, the answer would be 9, 10, negative 6. So again, that would be a solution that would work for that problem. All right, that was a toughie. All right, we've got a little bonus section here. We're going to go ahead and do 2 of the problems on the back so I can make it nice and colorful for you. So we are trying to figure out the x and y and z intercepts. So hopefully in your classes you talked about what the other values would have to be. If I want to be somewhere on the y-axis, so I am talking about right in here, the x-axis right in here, what I would need to have is I would need to have zeros for both of those values there. So that's actually what I'm going to do. I'm going to go ahead and plug in zeros. And these always cancel out, which is so gorgeous, and leaving you with x is equal to 4. So we're going to put a nice little 1, 2, 3, 4. That is a point. We don't connect it to any other points yet. This is just, that is the point, that is the y-intercept. We're going to find the y-intercept. And so when we do that, when we plug a 0 in here and we plug a 0 in here, those guys will cancel, really leaving you with simply 4y is equal to 12 to solve, and the answer would be 3. So again, the reason for that is I plugged in those values. So that is actually a point now in the y-axis. It's hanging out right there. And we'll go to blue. So for the blue, I plug in, I get zeros for both of those. You end up solving z is equal to negative 6. And again, y, because I plugged in zeros for the x and the y. And I'm down here at 1, 2, 3, 4, 5, 6. So at this point here, we do want to go ahead and connect them all. It's not just a triangle, it really is much larger regions from there. And then we kind of nicely shade to indicate that it's all of that section there. Here's our last one. We're going to go ahead and look at a bunch of different points. So we'll start off with A. I'm going to use blue to indicate what's happening. So I'm going to go 1, 2, 3, 4. I'm going to go this direction here in the X. Then I'm going to go 1, 2, 3, 4, 5. That direction there in the Y. And then I'm going to go up 1. So this here is my A value. Let's go ahead and change color so you can see what's going on here. For the B, I'm going to go out 1, 2, 3. But then this time I'm going to go -2. Now make sure that it is parallel. So if this is the y, I need to make sure that I'm parallel to the y-axis there. And then I want to just go 0. So bam. That is my b value. Switch to green, looking at C. So with C, I'm not going to go anywhere in my x direction. I'm not going to go anywhere in my y direction. The only place I'm going to go is up 1 in my z direction. So that is my point C. All right, I am going to change colors to lavender. That looks exciting. All right, so we're going to go ahead now and look at D. I'm not going to go anywhere in the x direction because it says 0 there, but I'm going to go in the y direction and then down in the z. So we're going to go 1, 2, 3, 4. So 1, 2, 3, 4, all the way to there. And then from there I'm going to go down 1 right there. So that little point there is letter D. All right, I'm going to switch colors again. We're going to do light blue. That should be fun. So we're going to do this guy right here. We need to go out 6. So I already went out 1, 2, 3, 4, 5, 6. So here is where we now are. I'm going to go ahead and make that nice over all of them. And then I want 1, 2, 3. So I want it to be parallel, remember, to here. So all of these guys need to be parallel. So we're headed in that direction. You may not be very good at it at first, but hopefully you improve. And then from there, whoopsies, we're going to go up 1. So that point there is E. All right, we've got one last little dude to go. We'll do a nice salmon color. This guy right here. So here I am going to go back 2 first in the x direction, so I'm negative. And then I'm going to go back 2 in the y direction, also negative. And here's a tricky one. It looks like it's exactly in that same spot as the C was, but in actuality, if you were able to see this 3D, it would be in a different spot.